So what we'll be learning today, we'll be learning Terraform actually. So we have a document actually. So I'll go through this document and I can explain the concept of Terraform and how it is useful. And we'll install Terraform on Amazon Linux and we'll write our simple Terraform script actually. Okay, let's go ahead and get started. So what is Terraform? Terraform is an open source infrastructure as a code tool developed by Harshika. Who owns CloudFormation stack?
Amazon.
Exactly. So the CloudFormation stack owned by AWS. So you can automate only AWS infrastructure using CloudFormation. Let's say if you want to automate, let's say you have some infrastructure in other cloud, for example, Google Cloud, GCP, or Microsoft Azure, or IBM Cloud, any other cloud. So you cannot use CloudFormation for other clouds actually, it won't support. Okay, but the Terraform will support all cloud providers basically. Okay, so what it does is, so with Ansible, what you have done is you created an instance. For example, you created an instance. Okay, so you created an Ec2 instance. That instance can be managed by you. Managed, when I said that managed by you means you could go there, you can make any changes to that instance. Ansible doesn't care. So if you run your Ansible playbook to create an Ec2 instance, and let's say how that instance is being created. Did you use Ansible? Did you use CloudFormation? If it is CloudFormation, you will know, because you can go to stacks and you will identify in the resource section and you will click on the resource, you will see that Ec2, which is fine. But if Ansible creates an instance, Ansible doesn't even know. You used Ec2 module, Ansible create that instance, and after 4 or 5 days, like after a month, you went there, and how you can make any changes that you want. Ansible doesn't even manage that infrastructure basically. So when I say manage means you created some infrastructure, right? Ansible doesn't capture that infrastructure. Does not capture that infrastructure. When I said capture that infrastructure, you created this portion of infrastructure and Ansible did it for you. Ansible did it for you, for example, and there is no such a thing called, okay, this portion of infrastructure created by this Ansible playbook. Because whatever you will say, it can go ahead and just do the job. That's it. It doesn't maintain any what we say, like any kind of state file. What is the state of this infrastructure? For example, instances are there, what is the VPC ID, what is the subnet ID, and what were the security group, inbound, outbound routes, all that kind of stuff. Ansible doesn't care. As long as you tell something to Ansible, it can create that infrastructure. If it is a CloudFormation stack, what you can do, you can create a CloudFormation stack. Okay, you can create a CloudFormation stack. When you delete this CloudFormation stack, the entire infrastructure has been deleted. Okay, this is one opportunity. Okay, that's fine. Hey Vishnu, why would we delete that infrastructure? Okay, let's say for example, it's a testing infrastructure, testing environment. You did test your application properly. You did test the jar file properly, or you did test a Docker image properly. You don't need that infrastructure. Why would you want to pay for testing infrastructure after testing is done, right? In that scenarios, what you can do, you can just simply go there and delete your CloudFormation stack. Whereas if you use Ansible, you won't have that opportunity. You would have to write one more Ansible playbook to delete the infrastructure. Am I right or wrong? What we did create like a EC2 instance using Ansible, and we did write another playbook to terminate EC2, right? Example, just for example, okay. Whereas the advantage with the Terraform is you can create infrastructure using Terraform. You can create infrastructure. By the time you create infrastructure, it will generate a file called a state file. State file. What this does is this file capture the created infrastructure. Okay, this file completely capture the created infrastructure. For some reasons your infrastructure is gone and you had some instance IDs, you had some data that you didn't want to lose, but you lost the data. But this state file can have complete infrastructure basically. Okay, it maintains the state file. And hey Vishnu, that's fine. You said it maintains the state file, but what if I create an infrastructure using Terraform, for example, and I make some changes to this infrastructure? How this state file is going to get that changes? No, it's not going to get those changes actually. When I said that, let's say you have created an EC2 instance, for example, and you have update, you use Terraform to create EC2 instance, and you went there, you log into your AWS management console, you update the tag manually. This state file doesn't capture that update. And when you run this Terraform script again, the state file will delete that. The state file manage like a sync. This state file will sync with the actual Terraform module. Okay, actual Terraform module. So you have that state file. For example, when you create your infrastructure, you have that state file. Okay, this is the infrastructure is being created. That is good. And for some reasons, after proper testing, and you had to terminate that infrastructure, you use the same script to terminate the infrastructure. You don't need to write another script actually. Okay, you use the very similar same script, not similar actually, you use the same script to terminate the infrastructure as well. Okay, are you guys with me? Can you guys type Y in the chat if you are with me? Okay, so what we have in that Terraform, we will have a main.tf, the file name main.tf actually, main.tf. When you run Terraform commands, it will look for this main.tf. Remember, if you run Docker commands, the Docker build, it will look for the Docker file, right? The interpreter look for the Docker file. Same way, when you run Terraform commands, we'll get there in very in a minute actually. This will look for the main.tf file, and you will have a variable.tf file, and you will have an output.tf file. Those two are not mandatory. You can add those output and variables inside this main.tf as well. Okay, once we have a sample script, it will be very easy to understand. Let's go ahead and get started. Let's install Terraform on EC2 instance. Am I clear till now? Okay.
Yes, Vishnu.
So the core concept are like a variables, used input variables. What are the variables? Some example variables like instance type, AMID, region, all those examples for variables, right? The providers means whether it's AWS provider, Azure provider, DigitalOcean or GCP provider, or any other cloud provider, or like a OpenStack provider, things like that. Okay, and a module is nothing but a directory with a Terraform infrastructure. When I said that, you have a main.tf, you create a folder, and you have a main.tf there, and whatever you will say in that main.tf, you have to run Terraform command at that main.tf location. So that entire folder can be called as a module, simple way. Okay, modules are nothing but like Terraform modules are nothing but it's a portion of a network. You can have a complete infrastructure or portion of an infrastructure. Okay, very simple. And the state is cached information about the infrastructure. We just discussed about that, right? When you apply your infrastructure, it's going to capture a state file. That's a cached, the information about your infrastructure. What was the instance type? What were the tags? What was the security group name for that instance? All that kind of stuff. Okay. So inside resources block, remember inside resources, what we did in the CloudFormation stack, we did provide the resources, right? Inside resource block, we did provide the resources, right? Same thing in the resources block, you will be configuring your infrastructure. For example, let's say you want to create a VPC, you will be providing VPC. You want to create a EC2, you'll be providing EC2, things like that. Okay. Output will get you the output of a specific a resource. Basically, it's the same like you have output and a get attribute, right? For example, something like that. Okay. Plan, what it does is, in order to test Ansible playbook, what you have done, you have to run Ansible playbook, Ansible-playbook, and run. And you've got an error. Hey, register module is not belongs to some XYZ module, something like that, right? Or even in the CloudFormation stack, you wrote the CloudFormation stack and you tested it, and you did mismatch something, and you had some syntax error and stuff like that, and you had to apply. That means you had to run the script in order to get those details. In order to, once you got errors, then only you were able to resolve those errors, right? But in this case, no, you don't have to apply. That means you don't have to actually create the infrastructure in order to test it. What you can do, you can plan it. That plan will tell you what were the changes were missing before even create. Okay, for example, syntax. For example, you were missing some variable and things like that. Okay, then if everything looks good, then you can apply. Okay, we'll see very simple example actually. So let's go ahead and get started. So these are the Terraform lifecycles basically. So Terraform core, which is Terraform what we write, and the providers. These are the providers. Okay, so you like as the developers write the configuration files, which is main.tf, variable.tf. Terraform core, what it does is it caches that state file and it creates this infrastructure. How simple is that? Okay, and we'll install Terraform on Amazon Linux, and we'll write a simple Terraform script to create one more instance. Okay, any questions till now? Can you guys type Y in the chat if you are with me? Okay, so let's go ahead and get started. Create an EC2 instance. We are going to use Amazon Linux as well. I'll opt for the old experience. Launch and launch. I'll use I am user keeper, and let's go ahead and run this. Okay. So this will take a minute. So meantime, what we can do, let's go grab that IAM credentials, because so when you create a IAM user, you provide two types of credentials, right? Programmatic access and console access. Pretty much you'll be using programmatic access all the time, because nobody is going to create resources from the console. Because when you create the resources from the console and you have the resources for one environment, and if you want to create the resources for another environment, those resources might be different. When I say different, let's say you choose T2.micro for one instance and 90 instance, but you miss two of them and you choose different because you are selecting, right? And mistakes can happen. Humans make a lot of mistakes, right? Your intention was 90 EC2 instances with a T2.micro, but you had 88 only. Two are them like a different actually. Okay, but if you are using the script, it won't happen because you are defining the instance type just once. You are applying the script. That's it. Did you guys get my point? That is why everybody create their infrastructure using infrastructure as a code tools like a Terraform or CloudFormation or Ansible. Okay, so let's go ahead and connect to this EC2 first, and we can install Terraform, and we'll run our sample Terraform scripts to create EC2 instance. So the reason behind that, I said that, so we are going to use that access key, secret key for that IAM user actually. Okay, so let me go there. Let me connect. Let me install sudo yum update -y. Okay, so I'm going to use this documentation. This is some utils, yum utils. This is Amazon Linux actually, Amazon Linux based configurations. So I'm going to go grab that and I'll run that. Let's install yum utils. Okay, everything is latest version, so we are good there. Now let me go download this repo. You see that I am downloading this harshikap.repo and putting that repo into, where am I putting that repo? Adding that repo. Okay, so just download that repo and adding that repo to yum config manager. Okay, something like that. Get that repo. Okay, repo is saved. Where is it saving? You see that? Ec yum repo harshikap.repo. That harshikap.repo, Terraform was not there. Terraform was not there inside this yum.repo. So you cannot use yum to install Terraform. Now you have downloaded that harshikap.repo. Now you are going to use yum to install Terraform. Does that make sense? Can you guys type Y in the chat if you are with me? Okay. So let me go install Terraform. Then we'll check the version of Terraform just to make sure the Terraform installed properly. -V. You see that Terraform 1.2.9 has been installed, which is good. Now let's go ahead and create our what we discussed module, right? Module is nothing but simple directory, but I'm going to use this documentation so that I will send this documentation with you guys so that you guys can have that details as well. Okay, so we are going to use this documentation on entire this section. Okay, so we have installed. Now we'll have to export. If you don't export, what you will see, you will have an opportunity to provide them inside the script, but nobody does that. Nobody can provide this access key, secret key inside the script. Is that fair enough actually? Because it's not safe. It's not safe. You're going to keep that access key, secret key inside the GitHub repository, and your GitHub. There are a lot of people who can access your company's GitHub repository, right? At least readable access. So it's not a good idea. Nobody does that. So we'll export this access key, secret key. Okay, export AWS access key, secret key, but let's see. Do I have access key, secret key? We'll see. Give me 1 second. So it's going to look for that AWS access key. What is that? So export access key equals to and we'll have to provide that access key actually. So what I'm going to do I have that access key secret key? Okay, I think this one has it. Hopefully this user exists. If not, I will have to create an IAM user. You guys are getting me, right? You guys are getting me what I'm doing, right? I'm just trying to configure this access key, secret key, so that I don't have to provide them inside the script. Remember, we did same thing for Ansible. We did configure access key, secret key, so we didn't have to provide that access key, secret key inside the script actually. Okay. Can you guys type Y in the chat if you are with me? Okay, that's good. So let me go add this access key. Now let me go export the secret key. Export the secret key and get the value. Where is the let me go grab the secret key, copy, paste it. So we are good. We have configured access key and secret key. Now, so what we can do, so right, like just to create a simple module, learn a Terraform AWS instance module. It's a directory and mkdir. We are going to use mkdir command to create that directory and go to the directory. Now, so what we discussed it, look for that main.tf, right? Look for that main.tf file actually. When you will have 4 Terraform commands. First one is Terraform init. What it does is it will initialize this module. Let's say if you're running Terraform commands and a different module, and you would have to initialize that module. To do that, you will have to run Terraform init command actually. So for those 4 commands, those commands will look for this main.tf actually. When you run Docker build, how the Docker build look for the Docker file. When you run Maven package, how that Maven package look for that pom.xml. And when you try to install prerequisites and Node.js, how it look for that package.json, right? Very similar. When you in a Ansible playbooks, it's a different story. You will provide the playbook name. It doesn't matter if you have a multiple Ansible playbooks there, but what if you have a multiple main.tf? It is going to be a conflict. So you will have a one main.tf at one specific module actually. Does that make sense? Can you guys type Y in the chat? So let's go ahead and create a file name called main.tf, and we are going to use the touch command to create main.tf. Okay. Now let's go add some content to that main.tf. Simple Terraform script actually. So let me go add. Is there any way that I can copy? Yes, something like this. Copy. Okay. Set paste. I'm going to use set paste. Insert I. I'm going to paste it here. Okay. So what are the changes that I should make here? Can you guys help me? I'm not providing any access key secret key here. You know why I'm not providing any access key secret key? Because those access key secret keys are configured, right?
Okay.
Yes. So here, So let's see. The first one is required providers. What is the provider for EC2? Which is AWS. Okay. The source is, you see that Harshika of AWS is the provider, first one. And which version, 4.16 or whatever version, that they will tell us. Who will tell us? The AWS provider will tell us, and we are good there. That is good. So we have the provider on the first section. You see that this is the provider. Okay. And in the resource section, you will be creating instances. Each and every resource section, whatever the resource that you will be trying to do, you will be providing that. Here, I'm creating. So this is the main AWS underscore instance is the, you can say, resource. Actually, that's the, when we try to create a EC2 instance, what a CloudFormation stack does, something like a type, right? Type. And Ansible EC2, it's a module. Very similar. Inside a Terraform, it's AWS underscore instance is a resource to create EC2 instance. And just this is just for a reference, app server, just a reference for that EC2 instance. Okay, and providing that AMI, these are the variables that we are trying to provide. Let me go grab those AMI value here. Okay, and grab that AMI value. Are you guys with me? Can you guys type Y in the chat if you are with me? Okay. Let me copy this AMI ID. Just here. And the T2.micro is fine. And let me go ahead and run. Save this. Okay. Next, let's follow this documentation throughout the execution part. Okay. So we have those values defined. This is US West 2, right? We'll change that one as well. Okay. So what happens is you will have to initialize this module first. Okay. So in order to initialize this module, you will have to have a Terraform in it. That's it. But before that, let me go change AWS region as a ES East 1 because I don't want to create anything. Just 1. Okay. Once you have this module ready, the module is nothing but a directory with a main.tf. You can say that. Okay. It will look for that main.tf, and you need to initialize that module using init command. So the Terraform module will initializing the provider plugin. You see that? So Terraform has been successfully initialized. We are good there. Now, before you create your infrastructure, that means before you create your EC2 instance, in our case, let's test it. How can you test it? Terraform plan. The Terraform plan will get us, okay, hey, you see that? So what are the things will be adding to your instances? These are the things that are going to be added to your instance. So CPU core, ARN, instance type, and tag this one, because we'll be providing the tag from the script. So Terraform will know that one. But all these volume ID, volume type, these plus values, these plus values are going to be added to your state file. At the same time, if you apply this tag, these are this instance metadata. When you create your instance, when you select a description, you will see the metadata, right? EBS volume, snapshot ID, all that kind of stuff. These are the details that are going to be added to your instances. That's what we are saying. We haven't created anything. If I go there, if I go to AWS, and I don't see anything, because we haven't created anything yet. Actually, we haven't created anything. But if there is an error, this will tell me, okay, there is an error. Okay, so you cannot create anything. Okay, now let's go ahead and create a plan. Actually, yeah, let's go ahead and create a Terraform apply. Just type y. You see that AWS underscore instance is a resource creating. Under that, this is a reference actually. Okay, if I go to AWS and if I refresh it, you see that there is one more instance is being created. The instance name is example app. You see that example app. Okay, now so one resource has been added and the instance ID is this. And if I do ls here, you see that there is one more file called cache of your infrastructure. If I do cat that file, this file will have all the data. What is the security group of that instance? What are the tags for that instance? What is the EBS volume type for that instance? Instance IP and instance ID, ENI, complete instance metadata, what type of instance it is, everything. Even if you lose that instance, right? Okay, I've lost that instance, but I need those instance ID for like a reports purpose or for any other purpose or things like that. What you can do, you can go to this file because Terraform already captured that file. You can go to this file and you can just, okay, you have that cache of that infrastructure already. Okay, this is the, let's say for example, let me go there. Let me try to add one more tag and let's see what happens. Okay, add one more tag, edit. Basically, not only tag, you are making some changes to your infrastructure. Let's put it that way. We are now just creating EC2. That is the reason we are trying to make some changes to that EC2. For example, we are adding a tag. What if you are creating multiple resources? Let's say for example, you want to create an IAM user and you want to attach a couple of policies to that user. You want to use that user to create a EC2 instance, and you want to use that user to create a S3 bucket. All these tasks you are doing inside a single Terraform script. And obviously there is bunch of data that can be captured, right? And if you want to make changes to your S3, which is being created in your using Terraform script, it's not going to capture those changes actually, because if you are making changes from the console, and let's see, I'll show you how does that work. Okay, app equals to something like a Macy's. Let's put it that way. Macy's is the app. So I have added this, right? And let me try to apply this Terraform apply again. So Terraform apply. Okay. What happens is, you see that? So this is not going to create one more instance. Okay, because you have instance already with the app server reference. You have that instance already. Okay, so what it is going to do is, hey, we haven't seen these changes. We haven't seen these changes in this Terraform file. So we are going to remove these changes to sync your infrastructure with the Terraform. With the Terraform means you have created your infrastructure and we have the file, what file you use to create your infrastructure. We are going to sync your infrastructure with this script actually. So you can use the same script for other environments as well, because there is no way that, okay, I've used these tags in dev and I've used these AMIs in prod, things like that, right? Because it's gonna cache that value actually. Okay, if I do yes, right, it is going to remove that uh, it is going to remove that extra tag that we just created actually. Whereas if you use Ansible playbook to delete to create instance, right? What it does one more. It will create one more instance. It doesn't care. It doesn't capture anything. It doesn't care as long as whatever you are telling Ansible, it's gonna go and do that. That's it. Okay. So you see that now your actual infrastructure, which is EC2 infrastructure, has been synced with your Terraform script. Okay. Let me go. You see that the state file has complete data. Okay, tf state file has everything needed. This is the complete metadata of that instance. Now let's go ahead and terminate that instance. You are using same script and you will be using destroy command this time. Okay, Terraform destroy. Let's say you have IAM role, you have a policies, you have a lot of things that you've been testing. After your testing is done, you want to delete all of them in a single point, in a single command. You can use the same script that you used to create those resources. You see that this negative means this is going to be deleted from your infrastructure. That's what it means. The red minus means it is going to be deleted from your infrastructure. That's what it means. Okay. And if I do yes, so this instance won't be there. You have that instance ID even though instance is not there, for your future purpose or for what could be the instance IDs and things like that. If I go to our EC2, let me refresh it. You see that shutting down that instance actually. Okay, are you guys with me? Can you guys type Y in the chat if you are with me? Okay, any doubts till now? This is how Terraform works actually. Okay,